Alright, hi. Today we'll be talking about natural logarithmic function and integration. Okay, so first off, the basic definition for a function that is a reciprocal. The integral of a reciprocal is the natural log of the absolute value of x plus c. So that's pretty simple. Okay, now the integral of the natural log of x is a little bit more complex and you have to use substitution by parts, but you will get x plus the natural log of x minus x plus c. Okay, so that one's pretty simple. Alright, so I already have some examples written out here for you. The integral of x squared over 3 minus x cubed dx. Okay, and I went ahead and did the basically just the substitution part. Okay, so I did u is that, and I found out I had a negative 3, but I didn't have a negative 3 there, so I did the calculus trick of having a negative 1/3 and a negative 3 at the same time. Because if you remember, negative 1/3 times negative 3 is equal to 1, and I actually technically do have a 1 right here. I just never write it, and that's the calculus trick of using it. Okay, and then once I get that, I find that this whole part right here will turn into du, and then will become du, and then when I do the integral of it, I get the natural log of the absolute value of u. And then all I do is replace u with what it actually was in the beginning, so it's actually kind of cool. Now, this one's a little bit more complex, okay? But if you notice, when I get done treating this, because obviously this is the part that has to be differentiated to get to this part. Okay, when I do all my differentiation, I get down to something that is 3x squared plus 6x. Okay, well, if I factor out the 3x, I now have 3x times x plus 2, which is exactly very close to this. So once again, I use the trick, the calculus trick of 1/3 and 3. Okay, and then this becomes 1 over u times du. Okay, and then I get 1/3 times the natural log of x cubed plus 3x squared minus 4 plus c. So that's just the absolute value. Okay, now some other things. The integrals of famous trig functions right here. The integral of sine of u du, especially when you're using some trick in working with substitution, is going to be negative cosine of u plus c. The integral of cosine of u du is going to be sine of u plus c. The integral of tangent of u du is going to be the negative natural log of the absolute value of cosine of u plus c. The integral of cotangent of u du is going to be the natural log of sine u plus c. The integral of secant u du is going to be the natural log of secant u plus tangent u, absolute value, plus c. And then finally, the integral of cosecant of u du is going to be the negative of the natural log of the absolute value of cosecant u plus cotangent u. Okay, and we won't get too much into examples for these ones, but I do want to give you some guidelines for integration, okay? Alright, so some guidelines for integration. Memorize a basic list of integration formulas, including those given in this section. You now have 12 formulas: the power rule, the log rule, and trigonometric rules. By the end, this list will have expanded to 20 rules. Okay, so just so you know, there is a whole bunch of lists and stuff of other trig rules too that actually help too. But these ones are really the cool ones that involve natural log. Find an integration formula that resembles all or part of the integrand, and by trial and error, find a choice of u that will make the integrand conform to the formula. So in other words, your substitution rule or u substitution, try your best. Okay. If you cannot find a u substitution that works, try altering the integrand. You might try trig identity, multiplication or division by the same quantity, or addition and subtraction by the same quantity. Just get creative with it. Okay. Alright, that's it for natural log and integration. I will talk to you guys later. Bye.